Hi everyone, this is Dr. Santosh Kumar MD, Assistant Professor, Jain Institute of Technology, Davangere. In this video, I am going to demonstrate an experiment called magnetic field intensity at the center of axis of a circular coil. I hope this video will be helpful for you people. So, in the next slide, we will look up what will be the steps we need to be followed to conduct this particular experiment. So, the steps we need to be followed. The first is to look up what will be the aim of the experiment. Upon that, we have to see that what are the operators required to complete this particular experiment, and later we have to look up what will be the formula which is there and which is used to do the calculation, and then we shall understand what will be the principle in the experiment and then theory which is behind in the experiment and what we need to be follow to conduct this particular experiment, that means method of conduction. Next is the observation of given data. So if any data are given, that need to be observed first, and then we have to go with certain conduction by understanding all the above points, and then tabulation of all the readings, and later we have to go for plotting and calculation by using the respective formulas. This we need to be follow to get a good result in this particular experiment. We are going to conduct this particular experiment with the following aim. First is to determine the magnetic field intensity at a center of the circular coil carrying current, and also we need to find the relative permeability of the core material of such coil. In order to conduct this particular experiment, we required certain operators. The first we required primary coil called as field coil, and secondary coil called as search coil, and central axis scale to measure the position of search coil. Next is Gauss meter required to sense the magnetic field intensity at the center of the axis of circular coil. Current source is required to feed the current to the primary coil, and AC power supply required. These are the certain operators required to conduct this particular experiment. Formula used in this particular experiment to determine the magnetic flux density at the center of the coil. So this is the theoretical formula, which is like this: B RMS is equals to V into 2 root 2 divided by pi F A N mu R. This will be in terms of Tesla, where V stands for induced EMF in the search coil, and BRMS is the root mean square value of the magnetic flux density. F is the frequency of AC source, that is 50 Hz, and A will be the area of core in search coil. It is a given value, that is equals to 2.73 into 10 raised to minus 4 meter square. N is the number of turns in the search coil, which is about 3,250 turns, and next is mu R is the relative permeability of the material of such coil. This is the first formula we are supposed to use to determine the magnetic flux density at the center of axis of the search coil. Next is another formula is relative permeability of the material. We need to find the relative permeability of the material by using this relation. Mu R is the relative permeability, which is equals to 2R divided by N into mu naught into B by I into 10 raised to minus 4. 10 raised to minus 4 is the factor of conversion from Gauss to Tesla, where R is the radius of field coil, which is about 9.75 into 10 raised to power minus 2 meters. N will be the number of turns on the field coil. It is 140 turns are there in the field coil. Mu naught is the permeability in free space, that is equals to 4 pi into 10 raised to minus 7 Henry per meter, where B is the magnetic field is recorded at the center of the coil in terms of Gauss, where I is the input current given to the field coil in terms of amps. So this is the second. In order to conduct this particular experiment, first we shall look up what is the principle and theory which is behind in this particular experiment. Later we will look up what is the method of obtaining the value of magnetic field intensity at the center of the circular coil. So this experiment basically based on the first law called as Biot-Savart's law. As per this, the magnitude of magnetic field intensity or magnetic flux density is directly proportional to the product of ideal sin theta and inversely proportional to the square of the distance between the current element and the point P. If you move away from the circular coil, what order of fraction of magnetic field which is received by the point P, that can be determined by the help of Biot-Savart's law. You can see in this particular figure there is a circle where the current element, the current carrying element will be there, in which the flux which is going to be generated, the order of flux directly fall on the P. What order of flux which is received by P, that can be determined by the Biot-Savart's law. Next is, so later another law which is going to be used in this particular experiment to sense what order of fraction of magnetic field which is received by the point P. So that is based on Faraday's law of electromagnetic induction. So as per this, if the rate of change of magnetic flux which is going to be linked with the coil, then it leads to generate the EMF. In simply, the magnitude of induced EMF in the circuit is equals to the rate of change of magnetic flux through it. So this is the Faraday's law. I will explain in the next slide how it will be, the Faraday's law will be works out in this particular experiment. Next is you can see that this is the experimental circuit. So you can see here, this is the bigger one which is shaded by the yellow color called as primary coil, so which can generate the magnetic field, hence which is called as field coil. The field coil which is connected to the AC source which is always providing the current for the primary coil means a field coil to generate the magnetic field, and the AC source it is, so hence the magnetic flux which is always going to be changed with respect to the time, so because it is an alternating current. So next is, you can see in the central coil is called as search coil or secondary coil. It can sense the magnetic field. So in terms of, as per the Faraday's law of electromagnetic induction, whenever the primary coil generates the magnetic field, those magnetic flux which is going to be linked with the secondary coil, that is exist at the center, that also supposed to generate the EMF. The induced EMF in the secondary coil, as per the Faraday's law of electromagnetic induction, which is going to be calibrated with the help of the Gauss meter. The Gauss meter can measure first initially EMF. That EMF will be converted in terms of magnetic field. So whenever this particular search coil which is moved along the axis of the center, so at the center, then it can receive the different orders of magnetic field. That different orders of magnetic field, that is going to be move away from the center, either it may be left side or it may be a right side, so which receives some order of magnetic field. That is, whenever it is exist at the center, it can receive the maximum order of flux, hence it can generate the maximum current, that means maximum EMF directly proportional to the order of magnetic flux, hence more magnetic field, that is higher order of magnetic field which is measured at the center. If it is moved away from the center, it is inversely proportional to the square of the distance, hence the magnetic field is also gradually decreases. You can see this is the particular experiment. So this is the primary coil, where in which the current going to be passes, because of that the magnetic flux is going to be, this is the current, this is the number of turns exist in the primary coil, and it can generate the magnetic flux. Those magnetic flux directly fall on the secondary coil. That secondary coil means a search coil. Because of that, it can generate the EMF. That EMF given to the Gauss meter. The Gauss meter role is to convert the induced EMF in terms of gas. This will be the main principle and theory which is behind in this particular experiment. So in the next slide we will look up what will be the procedure, how to conduct this particular experiment with the help of certain methods. Let's understand where is the primary coil and what will be the number of turns, where will be the secondary or search coil, what will be the order of number of turns, and where will be the AC source, and where will be the gas meter. So first is, this is the primary coil called as field coil. It has the number of turns that is equals to 140 turns are exist in the field coil. Next is, so the respective permeability of free space will be 4 pi into 10 raised to power 7 Henry per meter. The number of turns in the search coil, this is the search coil, this will be the search coil, central one is the search coil, and the number of turns in the search coil is 3250 turns are exist, and the respective area of core, so the search coil which is exist in the certain core and whose area will be 16.6 millimeter into 16.6 millimeter, which is the order of 2.73 into 10 raised to power minus 4 meter square. This is the area of search coil, core of the search coil, and the order of EMF, that is going to be generated because of the magnetic field at the center, which is equals to 0.9 volts. Whenever the search coil which is exists at the center, the order of EMF is going to be generated, that will be equal to 0.9 volts. Next is, this is the AC source. It is an input current which is going to be given to the field coil, and the input current is about 2 amperes, and the respective input voltage will be 4 volts, and the respective frequency of input source is 50 hertz. Next is the gas meter. The gas meter is, it can sense the EMF, and that will be converted in terms of magnetic field. This is the gas meter, and which has the display, and you can see directly from the display what order of magnetic flux which is going to be measured in terms of gas. Next is, this is the axis scale. So the axis scale important role is to look up what will be the position of the search coil that can be recorded in terms of centimeters. So now it will be there at the center, the position of the search coil is 0. So if it is move away from the center, it may be left side or it may be right side, so based on which we can record the magnetic field in terms of centimeters. So the axis we will position first 0, 2, 4, 6, 8, 10, likewise away from the center on both sides, left side and right side. By positioning that, we can measure the respective the field which is going to be generated in terms of gas. This is the operators. You can see the operator consists of steward gauge setup, in which we have the primary coil and the secondary coil which is exists at the center of the axis of primary coil, and it is having a provision for the moment along its center of the axis. So now the search coil or secondary coil which is at the center, which is connected to the gas meter. So you can see this is the gas meter. It can sense the magnetic field which is generated by the primary coil. Okay, now it is about around 1.9 or 2. So now we have not connected the power supply to the primary coil, hence no magnetic field. It is the zeroth magnetic field, that means a rest value. Now you can connect the primary coil to the power supply. No need of worrying about the positive and negative, because we are connecting the primary coil to the AC source, hence it did not have any positive and negative terminals, hence you can connect any terminals. So now it is connected, and then the primary coil is continuously generating the magnetic field that fall on the secondary coil, and the secondary coil is supposed to be generates the magnetic field. That magnetic field is about 63.9. Initially it was 1.9 or 2. Now it will be showing 63.9 or 64, and this will be the magnetic field which is generated, which is going to be received by the secondary coil when it is exists at the center. Center means it is the scale. You can see there is a scale which is going to be graduations. This graduation scale which is used for the purpose of keeping the secondary coil on either side of the primary coil. Now you are supposed to record the magnetic field which is generated at the center, that means 0th point, and enter it in the tabular column. Then you are supposed to move the primary coil in any one side and adjust 2 centimeter from the center. So this is now new position of the coil which is moved along the axis from the center 2 centimeter. So now it is showing 62.5. So then further 2 centimeter you need to be moved and keep the secondary coil to the 4 centimeter from the center. So now it is at the 4 centimeter from the center of the axis. Now it is 58.6. Likewise you need to move till the last reading, that means about around 20 centimeter. Okay, 10 readings we will get in the right side. Similarly you need to take the readings from the center on other side. You have to move and note down the readings for every 2 centimeters till it reaches to 20 centimeter on other side of the center of the circular coil. This is the simple reading. Upon noting the readings of these, so you need to enter those values in the tabular column. I can show you now what will be the tabular column. Upon entering all the values in the given tabular column, so this is the tabular column, you can see. So the distance from the center in centimeters 0 to 4 6 centimeters, likewise till 24 centimeters from the center. So we have measured the magnetic flux density in terms of gas in left side and right side both. So you can see at the center you can see there is a maximum order of the magnetic field which is going to be generated. So if it is move away from the center, the gradually decreases. So upon this you will go for plotting the graph. This is the kind of variation. So that is here you can see the respective scale. The respective scale will be about along the x-axis. It is in terms of centimeter. 1 centimeter is taken as 2 centimeters, or 1 centimeter unit is equals to 2 centimeters, that is also in distance, and y axis 1 centimeter is equals to 5 Gauss. The variation will be like this, and the maximum field measured at the center. So that particular magnetic field which is going to be recorded, and that will be used for calculation purpose. Now the magnetic field at the center is 56.2 Gauss. 56.2 Gauss is the magnetic field intensity or magnetic flux density at the center of the circular coil, and that particular value which is used for the calculation of relative permeability and the respective magnetic flux density or BRMS value. So you can see the calculation in the next. Upon all measurements, first we shall calculate the relative permeability of a material by using the relation mu r is equals to 2r divided by n mu naught into b by I into 10 raised to power minus 4. So where r is the radius of the primary coil, so that is mu r is equals to 2 into 9.75 into 10 raised to power minus 2 divided by 140 into 12.56 into 10 raised to power minus 7 into 56.2 divided by 2 into 10 raised to power minus 4. So obtained value of mu r is equals to 3.116. This will be the relative permeability of a material exist in the core of this such coil. Next we will calculate the BRMS value by using the relation BRMS is equals to V into 2 root 2 divided by pi FAN mu r. So substitute all the values and we will get the BRMS is equals to 56.2 into 10 raised to power minus 4 Tesla, and then later we have to reduce this into Gauss, that is 56.2 Gauss we will get, and finally write the obtained two values in the result. I hope this will be helpful for you people, and thank you very much.